I'm serious.
It is Thursday, March 19th, 2015. We are on page 313. We're going to talk about the quadratic formula, which is another way of finding the zeros. Remember, so far you've learned how to graph quadratic. You've learned how to factor and solve for them. And then you learned how to complete the square. Now you're learning the fourth and final method there is to know about solving for quadratics. And I have written it on this lovely whiteboard, and it's going to remain there. Okay? So we'll talk about what it is and what it means in a second. But I also want to tell you that you are all going to memorize it. Memorize it. Okay? Just like I had you memorize the I cycle, it's just as important, because when you find the zeros of a quadratic function, the quadratic formula will always work. Always, always, always. Okay? So if you don't think you can factor it, then use the quadratic formula or completing the square, because both methods will always, always work. So who knows? Maybe you'll find that you like completing the square better than you like the quadratic formula. I don't know. Right? So the quadratic formula is this giant thing. It looks kind of intimidating when you first look at it, okay? But it's using the coefficients of our quadratic function. Remember, we can write any quadratic function as ax squared plus bx plus c equals 0, okay? And we can use a, b, and c in the quadratic formula, and that will help us find our zeros. Now, the book starts off by proving why this works, and we'll just read through it together so that you future mathematicians, Ella, will understand what a math looks like. Okay. Quadratic formula. Oh my gosh! And you're all going to write it down because it's really important. Okay. All right. Let's go halfway down the page, or about a third down the page, where it says quadratic formula. Dun, 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 in giant, capital, bold, scary letters. Let me know when you're there, Miss Stormy.
Fairness.
All right. Here I go. We have seen that exact solutions to some quadratic equations can be found by graphing the function. By graphing, by factoring, or by using the completing the square root property thingy. Okay. While completing the square can be used to solve any quadratic equation. So sometimes we had to estimate with the graphs, huh? Remember that? When it was like between two lines? And with factoring, we can't always factor everything pretty, because how can you figure out what multiplies to be 17 and adds up to be 5? And 17 is prime, so there's nothing, right? Sometimes we get answers like 4 plus radical 5. You know? So, that being said, the completing the square will always provide an answer. Okay? And so will the quadratic formula. So, fortunately, the book says, a formula exists that can be used to solve any quadratic equation of the form, and here it is again, ax squared plus bx plus c equals 0. The formula can be derived by solving the general form of a quadratic equation. So let's just read through this together. Okay? They start out with this general form, ax squared plus bx plus c equals 0. Okay? They divide out a, just like we did with completing the square. We get rid of it. So the next line is ax squared plus b over ax plus c over ax, or a, excuse me, equals 0, because 0 divided by a is still 0. Okay? And then they're following the steps. They move the c term over. Okay? Just like we do in completing the square. Ax squared plus b over a x equals negative c over a. So again, that just comes from subtracting c over a from both sides. Okay? And then they continue with the whole completing the square thing. Okay? Half of b, square it, add it to both sides. X squared plus b over ax plus b squared over 4a squared. U, okay, equals negative c over a plus the same thing on the right side, b squared over 4a squared. So again, they just completed the square and added that result to each side of the equation. And then, just like in completing the square, you separate it into their factors. Okay? In parentheses, x plus b over a, close, squared, equals this nasty thing over here, which is b squared minus 4ac over 4a squared. Okay? And they did some housekeeping there, obviously. Okay? They put the b squared 4a first, and then minus the b squared. Plus. So they switched everything around. And then you square root both sides, because that's how we undo a square. X plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. Okay? Again, that just comes from square rooting both sides, and it's nasty, okay? Because the square root of 4a squared is 2a, right?
Mm-hmm.
Then, here we have the quadratic formula by adding, or by subtracting the b over 2a from both sides. X equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Okay? And then they combine it to make it pretty like we did yesterday. So here, folks, is the quadratic formula. X equals negative b plus or minus b squared minus 4ac all over 2a. The square root of 4 b squared minus 4ac all over 2a. Okay. Now, they did stuff you did yesterday. Okay? They derived this crazy looking formula by completing the square. I think that's pretty darn fascinating, don't you?
Yes.
Okay? So, this is the moment where I need you to write this down. Okay? Write down this quadratic formula, because what you do to solve for zeros is plug in b, a, and c in the right places. That's it. Okay? So go ahead and write it down. X equals open fraction. Okay? Open fraction. Negative b. So minus b. Plus minus. Square root open. B squared. Bring it on down with a .5, so you know. Okay. Minus 4ac. AC. Close your square root. Now over 2a. Close fraction. Woo!
Wow.
Okay. So again, I'll reiterate, you're using the a, b, and c from your original quadratic formula. Equation, I mean to say. So your ax squared plus bx plus c, you're plugging those a, b, and c in this crazy looking thing, and then you calculadora it. Okay? So, I posted on Yammer a fun little song you might want to listen to kind of get it stuck in your head. And your homework will be to memorize it by Monday. Memorize. Well, I'll ask you on Monday. Ella's saying she's already.
How do you get on here?
It says you're in. You go to www.yammer.com. You can do it at home without the network, I hope.
Then put it in your favorites on your computer.
Yeah. Miss Chris says stick it in your favorites.
Okay, I have the app and it doesn't work.
Okay, well, maybe you should try it on your home computer where there's no network to get in your way. Firewalls and
Yeah.
that. So, the key concept box just reiterates. The solutions of a quadratic equation of the form ax squared plus bx plus c equals 0, where of course a does not equal 0, are given by the following formula. So that's why we say x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay? Because your first answer is going to be negative b plus the square root of b squared minus 4ac over 2a. And your second answer is going to be negative b minus square root of b squared minus 4ac all over 2a. Okay? Let's practice. Turn the old page. Find the page break. Very important. Because it always works, which is really, really cool. Okay? Example 1 is on the top of page 314. It says 2 rational roots. Remember, we talked about the difference between rational and irrational numbers the other day. Rationals are non-repeating decimals and whole numbers. So 0.25 is rational, so is 5. Okay? No radical 2s or radical 7s or anything like that. Solve x squared minus 12x equals 28 by using the quadratic formula, all nice and capital. Okay? Well, we have to do a tiny bit of housekeeping, right? Because remember, it has to be in the form ax squared plus bx plus c equals nothing. Okay? So how do we move that 28 over?
Minus.
Yep. So then our new equation is x squared minus 12x minus 28 equals nothing, right? So what's a? 1. That's right. What's b?
Negative 12.
Right. And what's c?
28.
Plus or minus?
Minus.
Minus 28. So for when you're first doing this, I encourage you to write them all down. Say a equals 1, b equals minus 12, c equals minus 28. So you know what you're plugging in where. Okay? But for now, you can follow me along. I'm at the line where it says then substitute these values in to the quadratic form. So negative b, okay? Negative b, you could just replace it, okay? So it says negative b, you would write negative, open paren, negative 12. Because unless you want to be savvy and cheat. But I encourage you to write it all out the first couple of times so that you get familiar with how this works. Okay? So negative, open paren, negative 12, close, okay, because that's negative b, plus or minus, then you got to open your giant square root, b squared, so again, open your parens and put negative 12, close, square it, and then minus 4 times a times c. So again, leave your minus 4 out front, and open paren, put your a in there, which is a 1, close paren, open your paren and put your negative 28 in there, close paren, because that's c. Yep. That's what I'm saying. You got to be super careful. And again, I'll reiterate, the first 2 times you do this, probably should write every single little step, and it might take 2 braille lines. Okay? Negative 12 squared minus 4 times 1 times negative 28. Okay? Then you got to close your square root, and then put an over sign, and then 2 times a, which was 2 times 1. Okay? So now you got no variables in there. Hooray! Now, all you're doing is crunching numbers at this point. Okay? So we know, if we look at the next line, x equals negative 12 becomes a positive 12, right?
Yep.
You have 12 plus or minus, open your root. 12 squared was 144, plus minus 4 times 1 times negative 28. Okay? Well, a negative times a negative, because we have 2 negatives and 1 positive, so 2 negatives will make a positive, right? And 4 times times 28 is 112. Okay? That's where they got that plus 112 when they did that calculation. So far in the numerator, we have 12 plus or minus the square root of 144 plus 112. Close root. Okay? Then when you add that all up on the next line down, keep your 12, okay? X equals 12 plus or minus. Now, open your root. Whatever 144 plus 112 is, turns out to be 256. Well, that's good, because that's a perfect square, thank goodness. Okay, all over 2, because 2 times 1 is 2. And then we get to the last line. You take out that perfect square. Okay, x equals 12 plus or minus 16 over 2. Okay, that 16 came out because the square root of 256 is 16. Okay,
Okay.
and that's all over 2 still. So then you can, and then they rewrite them like we did before. Okay, x equals 12 plus 16 over 2, or x equals 12 minus 16 over 2. Page 314, example 1, we're almost done with it. I did record, so then you do them separately, right? What's 12 plus 16 divided by 2? It turns out to be 14. And then you do 12 minus 16 divided by 2. That's negative 2. So you get your answers of x equals negative 2 and x equals 14. How about that? What do you think of the quadratic?
Mm-hmm.
What do you think, Stormy?
A lot of steps.
A lot of stuff.
Fun.
But I think you've been substituting for like 3 years now, right?
Yeah.
Yeah.
Mm-hmm.
So my best advice is copy it down real carefully, okay, your first couple of times through it, and double check your positives and negatives, right? And plug and chug, as I like to say. It's plugging and chugging. That's the basic idea. Now notice we had a perfect square in the square root. Lucky us, right? That's easy.
Yeah.
Not so nice the next time around. When the value of a radicand is, the quadratic formula is 0, then the quadratic expression has exactly one rational root. Well, that kind of makes sense. So this is important to remember. If you have a perfect square, you're going to have 2 answers. If you have 0 under the radical, you're going to have 1 answer, right? Because something plus or minus 0 is still always, plus 0 is the same thing as minus 0. But we still have to do the work, don't we? So let's try.
Mm-hmm.
Example 2. Solve x squared plus 22x plus 121 equals 0 by using the quadratic formula. So again, I'm going to ask you the same set of questions. What's A?
1.
1. What's B?
22.
22. And C?
12.
Uh-oh. I hope the Braille says 121.
Or, yeah, 121.
Okay, whew. Just checking. It could have been a Braille error.
No.
So again, I encourage you to write down A equals 1, B equals 12, and C equals 121 so that you don't get too confuzzled and you're not looking at the book and the paper and all at the same time. Okay? So remind yourself what the quadratic formula is. Josiah, since you're a newcomer, you spat it out for me? Yeah, all over 2A. Yeah. It's really important, otherwise you might not put it over the negative. Okay. Alright. So now we gotta start plugging and chugging. Okay? Negative B. Well, again, that's negative 22, right? Because B was 22. Plus or minus 22 squared. Ew, square root open, of course. 22 squared. This is where calculators come in handy, right? Minus 4AC, which is 4 times 1 times 121. Okay? All over 2 times 1. Ew, right? This is the part where you do a lot of calculating and they skip the step. So 22 squared is apparently the same thing as 4 times 121. Because on the next line they say x equals negative 22 plus or minus 0 all over 2. Okay? What's the square root of 0? What's the square root of 0?
0.
0. So you can skip it because negative 22 over 2 plus 0 is the same thing as negative 22 minus 0 over 2, isn't it?
Mm-hmm.
So when you do all that work, you finally get to, your answer is negative 22 over 2, which is course, when you reduce it, negative 11. So it's nice when 0 ends up in the radicand, isn't it? You're done. Of course, you can check it. They plugged in negative 11. It's all good. They used the calculator in the book. So is this making sense to you folks? Yeah, plugging and chugging. That's really all the quadratic formula is. And I repeat myself again when I say it works every single time. Whether you have a complex solution, the irrational solution, doesn't matter. It always works. Okay? And don't worry, we are going to spend Monday doing this too. Okay? Excuse me. All right, we're going to run through it again for an irrational roots. So I'm going to talk about 315. Or it says you can express irrational roots exactly by writing them in radical form. Okay? And that is the pretty way to do it. Your calculator can give you approximate solutions, but if you leave it as like 5 radical 2, that's exact. Now let's see what that looks like under the square root sign. Oh, hey, look! We have an a that isn't 1. How bad? Well, with completing the square, it was a little tricky, right? You had to make a bunch of halves and stuff. Solve 2x squared plus 4x minus 5 equals 0, using, of course, the quadratic formula. All right, what's A?
2.
2. B.
4.
And C.
Negative 5.
Okay. Somebody else besides Josiah spout off the quadratic formula to me.
X equals negative b plus minus the square root of b squared minus 4ac all over 2.
All right, Ella. Ding, ding, ding. Yes, and it's important. I'm making you repeat it so it sticks in your brain. Okay. Josiah will probably write it 10 times. Just kidding.
There's a typo.
Where?
In example 3, they forgot the 2a.
All right.
2a.
Well, now we got a plug and chug. We got a 4, we got a 2, and we got a C of negative 5. So negative b, so it's a positive 4, so it's negative 4. Plus or minus, of course, b squared, open root b squared, which is 4 squared. And then minus 4ac is minus a 4, of course. And a is a 2, and b is a negative 5. So again, keep them in parentheses so you don't get all confuzzled. All over 2a, which is 2 times 2. Okay? Which is, of course, 4. So when they do all this stuff, 4 squared inside for me, it's always easiest to do the silly radicand first, because it's what takes up the most calculation, right? B squared minus 4ac. So b squared is 16, right? And we have 4 times 2 times negative 5. Okay, so 4 times 2 is 8 times negative 5 is negative 40. So we have 16 minus negative 40 inside the radicand. 16 minus negative 40 is 56, right? Because minus minus makes you plus it. So that's why in the next line they have x equals negative 4 plus or minus the square root of 56 over 4. Okay? Now, they're not done, because radical 56 can be simplified. We learned how to do this in chapter 5. What is a perfect square that goes into 56? Miss Chris says 4 under her breath. 4.
Yeah.
Right? You can separate the square root of 56 into open root 4 times 14. Okay? And then we can pull out the perfect square. Okay? So that is negative 4 plus or minus 2 square root 14 over 4. That's where that 2 came from, because the square root of 4 is 2. Okay? So then, you can separate out your answers yet again. Actually, you can reduce it too, because negative 4, the 2, and the other 4 in the denominator all have a 2 in common. So they reduce this entire monstrosity by a factor of 2. Okay? And they got negative 2 plus or minus the square root of 14 over 2. Because again, they're pulling a 2 out of everything. Okay? So that, again, that's negative 2 plus or minus the square root of 14 all over 2. And then you can proceed by writing your answers separately. Okay? As negative 2 minus the square root of 14 over 2, and the other one, negative 2 plus the square root of 14 all over 2. Okay? Now, this is as exact as it gets. The square root of 14 is like, I don't know, 3 point something, okay, repeating. So you can just leave it this way. You don't have to calculate or do anything fancy like that. But just remember, if you have a radicand, that can be simplified like radical 56 or radical 50 or radical 72, okay, do so. Don't just leave it that way. If you can pull out a perfect square, go right ahead and do it. Okay?
I have a question.
Yeah.
On the step before where it says x equals, they're using an or in between?
They always use an or. Because remember the zero product rule, it's one, the other, or both.
Right, but then below it says the exact solutions are such and such and such.
Because they checked it.
Oh, okay.
See right there in the calculator? Now, if you check this by hand, forget it, right? So they use the calculator. And yeah, it looks like it's some crazy, 2.87025 thing. Yeah, and they rounded. Okay, that's why the exact solutions are the ones with the radicals in it. The one on the calculator isn't exact because they rounded. How does everybody feel about that?
Good.
You sure, Stormy? That sounds a little hesitant to me. So it's this chapter or section is all about kind of combining what you know from last chapter. Okay. Example 4 is when we get back to I, complex roots. Okay. Example 4. So far we've seen. I want you to notice in all the previous examples what has been under the square root. We've had a perfect square under the square root. That's 2b squared minus 4ac. We've also had nothing under the square root. And then we just got done with an irrational number under the square root. So if the answer is a complex one, what do you think is going to be under the square root of this formula? How do we get I out? Okay. Yeah, there's going to be a negative number under the square root. That's the only time we can ever get a complex number, right?
Mm-hmm.
I used to think it was impossible. Nope, I exist. Okay. So notice that number, that 4b squared minus 4ac, is actually rather important. And we're going to get to that real soon. Okay. Miss Chris is yawning. Are you bored?
Oh, I remember.
Oh, yeah. Mm-hmm. Oh, look, we got to do housekeeping. Example 4, complex root. Solve x squared minus 4x equals negative 13 by using the quadratic formula. Housekeeping, what do we do with that negative 13?
Plus it.
That's right. So then we get x squared minus 4x plus 13 equals nothing. Okay. Stormy, your turn to spout off the quadratic formula.
X equals negative b plus minus b squared.
Oops.
Or square root b squared. 4 AC
Okay.
over
Minus 4ac over.
2a.
All right. See? So I'll ask you on Monday too, and probably again today. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay? Pop the Weasel song. All right. Well, a is 1, b is negative 4, and c is 13. Okay? All right. So we have a negative b, and so negative b is positive b. Okay? So again, negative b, so if b is negative 4, the negative of that is positive 4. Okay? So again, they show the step where they plug it in and don't do any calculations. So they leave the negative outside of the parentheses, and then they write -4, close, plus or minus, negative, open root, -4 squared, minus 4 times 1 times 13, because again, 4 times 1 times 13 minus 4ac. All over 2 times 1, because hooray, there's no coefficient in front of the x squared term. Right? So when you calculate all of that, looky there, -4 is +4, plus or minus, ooh, looky there, the square root of -36 over 2. Okay? Because -4 squared is 16. 16 minus 26 times 2, 40, 52. Okay. 16 minus 52 is -36, all over 2. Okay. So again, 4 plus or minus the square root of -36 over 2. Now, what is the square root of -36 simplified to, folks? 6 what? 6i. Ella helped you out. Because remember, I is the square root of -1, so we can separate it into I times the square root of 36, which is 6i. Nice. All right. So then you rewrite it. 4, open fraction, 4 plus or minus 6i over 2. Okay? And looky there, the 2 can cancel with the 4 and the 6. How about that? Right? 2 goes into 4 twice, 2 goes into 6 3 times. So you can rewrite the whole entire thing as 2 plus or minus 3i. Hooray, no more fraction, right? One of your answers is 2 plus 3i, and the other answer is 2 minus 3i. And then, of course, they do it on the calculator, and see, what they're showing is that the parabola is not sitting on the x-axis, and it opens upward. So remember we talked about if the parabola does not touch the x-axis, it has no real solutions. So hint, hint, wink, wink, if it's not touching the x-axis, they have complex solutions, such as 2 plus 3i. Okay? I want to get through one thing today, one more thing, and that's talking about that b squared minus 4ac. There's a fancy word for that. Josiah, do you remember? Do you remember the fancy word for what the b squared minus 4ac thingy is called? Yeah! It's called the discriminant. So let's turn the page. So far we've learned that the quadratic formula is a giant plug and chug, right? And that you must be very careful when plugging and chugging. Now, we're going to talk about... Oh, they checked it. Hey, looky! They checked it. Oh my gosh. Look at that monster. Who wants to FOIL 2 plus 3i squared? I won't have you do that right now, okay? But you can check complex solutions. And -4 minus 9 is -13. So, it's kind of interesting how that you can check imaginary complex numbers and get real solutions out of it. Alright. I am looking at the roots and discriminant. Discriminant is a really important word. Okay, it's just the discriminant is the thing inside the radical. The discriminant, therefore, is b squared minus 4ac. And if you know what it's equal to, what kind of solutions you're going to have. Very important. Okay. I hinted at it. I did some foreshadowing through this whole lesson about this. Okay. In examples 1, 2, 3, and 4, observe the relationship between the value of the expression under the radical and the roots of the quadratic equation. The expression b squared minus 4ac is called the discriminant. And then they label it for you. They point it to it with an arrow. It's pretty hilarious. In print, they have the quadratic formula written, and it has an arrow pointing to the left of the into the radical, and it says discriminant.
Mine has like little lines on it.
That's pretty funny. So let's talk about what we learned. The value of the discriminant can be used to determine the number and type of roots of a quadratic equation. So the key concept box summarizes this for you. Okay? Value of discriminant in the left column, type of and number of roots in the middle column, and what the graph will look like in the right-hand column. Okay? So that's a lot of stuff. So if you have b squared, this is important for your notes probably, wink wink. Okay? If b squared minus 4ac is bigger than 0, okay, and it's a perfect square, okay, so like we saw in example 1, we got the square root of 256, okay, that happens to be 16. So if what you get under the radical is a perfect square, you have two rational roots, two real and rational roots. So they're not I, and you can calculate them. Okay? So again, if your discriminant is greater than 0 and it's a perfect square, important, b squared minus 4ac. The next type is if the b squared minus 4ac under the radical is bigger than 0, but it's not a perfect square, then you have two real irrational roots. So again, if you got 2 under the radical, okay, you'd have the square root of 2. There's nothing you can do about it. You can't simplify it. You can't move it out. You can't do anything. Okay, so you have, if is greater than 0 and not a perfect square, you have two real and irrational roots. You would leave it at something plus or minus radical 2. Okay. If your discriminant equals 0, you just have one root, and it's real, and it's rational. Because again, you're not going to have anything under the square root, right? Something plus 0 is the same thing as something minus 0. So you're only going to have one root. Okay? And lastly, if your discriminant, b squared minus 4ac, is less than 0, that makes it negative. So that should tell you right away, hey, look at there, I have I, because there's a negative under the radical. So you have two complex roots. Okay? So example 5 is just figuring out the discriminant and saying what type of roots you have. So again, if it's positive and a perfect square, two real and rational. If it's positive and not a perfect square, two irrationals. Okay? If it's equal to 0, one rational and real, of course. And if it's less than 0, you have a negative under the radical, so therefore you have a complex solution. Okay? Let's practice. We don't actually have to solve them. Hooray for us. Okay. So example 5 just says describe roots. So Stormy's probably after the tactile graphics of your pictures.
Yeah.
Okay, nice. Ugh, cough, cough. So find the value of the discriminant for each quadratic equation. Then, excuse me. Then describe the number and type of root we will have. Okay. So, what's the discriminant? Somebody. The little formula for it.
B squared.
B squared?
Minus 4ac.
Nice! So that's all we're doing. We're finding b squared minus 4ac for this 9x squared minus 12x plus 4. So, what's a? My little letter A of the example. A is
Oh, 9.
9, B is,
Negative 12.
and C is,
4.
yep, I was going to say 0 for some reason. No. Okay, and they wrote it here. A is 9, B is negative 12, C is 4. So, let's calculate b squared minus 4ac. Okay, so negative 12 squared, and then you would write minus 4 times 9 times 4. Okay, so turns out that is equal to 144 minus 144. What's that?
0.
Nothing. So if your discriminant equals 0, what does that tell you? Yep. Says it has one real root. She is correct. Okay. So again, if you can't remember, and it is hard to remember all this stuff, feel free to write it down, or at least the page number where that table's at. Okay. So you're right. Since the discriminant was 0, we only have one real root. Hooray! Okay. We don't have to calculate it. So the top of the next page has little letter. No, never mind. Next page to the right in print has little letter B. And in Braille, I'm assuming it's right below it. Here we go again. 2x squared plus 16x plus 33 equals 0. First, notice you don't have to do any housekeeping. Hooray! Okay. A is?
2.
Yep. B is 16, and C is?
33.
33. Hope you guys got your calculators ready. You're going to need them this section. Okay, here we go. 16 squared minus 4 times 2 times 33. Okay, well, 256 minus 264. Is that going to be negative? Yeah. So it equals negative 8. What does that tell us if the discriminant is negative?
Oh, 2 complex roots.
That's right, Stormy. Oh, I want to say it. Exactly, because again, you should always know the discriminant is under the radical. You have a negative number under the radical, so look at there. We're in I-land. All right. Next, little letter C. It's on the next page. Negative 5x squared plus 8x minus 1 equals 0. All right, A equals negative 5, B equals 8, and C equals negative 1. Okay. Again, the discriminant is B squared minus 4AC. So here we go. 8 squared minus 4 times negative 5 times negative 1. Woo. Okay, 3 negatives, so we're going to have a negative. 8 squared is 64, and negative 5 times negative 4 times negative 1 is negative 20. So we have 64 minus 20. 64 minus 20 is 44. Is that a perfect square? No.
Oh, no.
Nope, I wish, but it is not. So if 44 is positive and it is not a perfect square, what do we have going on?
Two irrational roots.
Exactly. Yep, because you can pull out a 4, so think about it. The square root of 44 becomes 2 radical 11, right? Because you say 4 times 11, and you can't do anything else with that. So that's irrational. 2 of them. Well, I bet you know what D is going to be without even guessing, right? Without even doing it. Which one haven't we touched yet? Okay. Yep, perfect square. So let's do it. D says negative 7x plus 15x squared minus 4 equals 0. Aw, man. Well, don't get confuzzled. They're out of order. So you can rewrite it as 15x squared minus 7x minus 4 equals nothing. Okay? Just to keep your brain straight around it. Otherwise, you might accidentally write 15 as B. E. Okay? So always double check that you read it right. Therefore, A is 15. B must be negative 7, and C is negative 4. Calculating the discriminant one more time. B squared minus 4AC. Okay. Well, B is negative 7. Negative 7 squared is 49. And then we have minus 4 times 15 times negative 4. So we have 49 plus 240 equals 289. Well, 289 is a perfect square. So if it's positive in a perfect square, what's going on?
Two rational roots.
Two rational roots. Yes, because you'd have something plus or minus 17. Because the square root of 289 is 17. Okay? That's it. A lot of information, huh?
Mm-hmm.
So the last thing I just want to briefly look at is there's a concept summary with all the stuff you've learned. Okay? Graphing. We've learned how to graph. We've learned how to factor. We've learned how to complete the square. Well, we've learned how to square root property, then complete the square, and then the quadratic formula. Graphing sometimes works, right? Because sometimes we land in the middle of stuff, or there's a parabola out in space that doesn't touch the x-axis, and then we just have to say, no real solution, okay? Factoring sometimes works, because sometimes you can get something that multiplies to be the C term and adds up to be the B term, but that doesn't always happen, as we've all learned. Then we learned about the square root property. That sometimes works. Right? You can't always have a factor in a perfect square form. Right? Sometimes you'll end up with, well, we've already seen many of those. Completing the square always works. Takes a bit of work, as you all figured out yesterday and the day before, right? Lots of fractions and everybody's favorite. Okay? And the quadratic formula always works. It will give you the complex and the reals and the irrationals. Okay? So now that you've all have learned every single method, okay, what's your favorite method, Stormy?
I don't know.
Okay, I'll come back to you. Ella, what's your favorite method, do you think? Ella says it's a quadratic formula. What about you, Josiah? What's your favorite method? Always. Well, if you want to know for me, my favorite is factoring, and if that doesn't work, then it's the quadratic formula. Because factoring just, I've been doing it for so long that it just pops in my head. What about you, Kathy?
All of it. Just all of it.
That's awesome. That's great. Stormy, did you come up with an answer?
I guess graphing? I don't know.
Graphing? No way. Oh. All right. I'm surprised. Most people hate graphing.
Well, sometimes. It depends.
Yeah. Well, how about today just start working on 4 through 7, okay? And Monday will also be a work day because I think this is very important. And you're going to have the quadratic formula memorized and the all over 2a part too. Okay? So, for today, just start working on 4 through 7.
Yeah, I remember it now.
Yeah.
Clear and
5 minutes, so if you can get through 1, I'll be happy.
like 4. Yeah, my